Hi, I am your educator Diptikant Padiyari, lecturer in botany. Welcomes to my channel Mikan's Botany. Please subscribe my channel. Hello, good morning. In this class, we are discussing about a new chapter, the DNA replication. In this class, we will discuss specially about the prokaryotic DNA replication. Let us discuss some. Let us remind some points regarding DNA. DNA is a genetic material. As we know, it is a genetic material. It is a double helical structure, double stranded helical structure, complementary strand. It has complementary strand and also antiparallel. And it has the nitrogenous base. Adenine always pair with thymine with double hydrogen bond. Cytosine always pair with guanine with 3 hydrogen bond. Here adenine is a purine base, purine nitrogen base, guanine is a purine, thymine is a pyrimidine base, cytosine is a pyrimidine base. Okay. In the DNA there is some bonds like hydrogen bond, which we have to remember this bond because these are very much important in the DNA replication process. Phosphodiester bond, and glycosidic bond. Okay, let's discuss about the prokaryotic DNA replication. Prokaryotic DNA replication. As we know, prokaryotic DNA is a circular DNA. Certain position from where replication will start in the prokaryotes called ORIC. Certain position at which replication will start. Position at which replication will start called ORIC. In prokaryote, only single ORIC region will present. Replication is bidirectional. Okay. Let's see the structure of a prokaryotic DNA. It is a circular DNA. Okay. It is a circular DNA having ORIC region or starting point of prokaryotic DNA replication. DNA replication is bidirectional, means the replication will be in this direction and also in this direction. Can proceed in both directions. Now let's discuss about the ORIC fragment. The region at which replication will start. Let's discuss about that point. ORIC fragment. Sorry. ORIC B.Sc fragment. B.Sc fragment is a 240 base pair, 245 base pair sequence. Base pair consensus sequence in length, out of 24 base pair, 13 base pair sequence, 13 base pair sequence, and 9 base pair sequence will there. Let's see the figure. You will confirm about this. If it is the B.Sc fragment, there will be 13 base pair sequence. This is the 13 base pair sequence. Sorry, 13 base pair sequence. 1, 2, 3. Okay, 13 base pair sequence, and there will be presence of 9 base pair sequence. 4, 2, 3, 4, 9 base pair sequence. Okay, 4, 9 base pair sequence. The sequence will be, the B.Sc fragment will be look like this. From here to here, the length will be 245 base pairs. Okay, 245 base pair. Okay, let's start with the DNA replication process. Okay, how DNA replication will start? There will be involvement of different kinds of proteins and enzymes, and in this we will see the protein and enzyme, then its steps, step by step, one by one. First, requirement of DNA replication in prokaryotes, the main protein, the first protein will be DNA A protein. Okay, DNA A protein. What is the function of its DNA protein? Its function to recognize the 9 base pairs consensus sequence. It recognizes 9 base pair sequence at which the replication will start. Here will be at which DNA A protein will bind. Okay, let's see the structure, how it will looks like. Okay, it recognize the 9 base pair sequence. Okay, it is the 9 base pair sequence, and the DNA A protein will get attached 30 to 40, about 30 to 40 DNA A protein will get attached. 30 to 40, these are the DNA proteins. Okay, DNA protein will get attached to it, and these are the 9 base pair consensus sequence. Then next protein will the HU protein or histone like protein. Okay, it recognizes the 313 base pair sequence and starts to unwind the DNA. It recognizes the 313 base pair sequence. This 313 base pair sequence is rich in 13 base pair sequence is rich in 8 adenine and thymine base pair. Okay, 8 is and causes this 13 base pair sequence. Sorry, HU protein recognizes the 13 base pair sequence and starts unwinding, means open the unwinding the DNA, the prokaryotic DNA. Then next protein will be DNA B protein. What happens when DNA B protein will bind? It creates a potential tension on the DNA. How? On the replication path. Let's see. If the DNA will opens, it will create a potential strain on the both side of the DNA because it is coiling each other. The two strands are coiling to each other. If we open, then there will be a strain on this side and there will be a strain on this side. Potential strain will be this side. Then it creates a potential strain on replication path. Okay. It does not work separately. It works with DNA C protein. It works with DNA C protein. Okay. Let's see the structure, how it looks like. It looks like this will look like such kind. Okay. For 9 base pair sequence. Okay, will be here, and here will be the, and something will be, I will leave here. The DNA functions as helicase properties. It has helicase property because it is on the DNA. Here will be the DNA B will bind. Okay, it starts to open the coil, open the DNA strand, and here will be the DNA B protein. Sorry, DNA protein. Here will be the DNA protein. This is the DNA B with helicase properties. Okay, the structure will be look like this. Then after sorry, here will be some information regarding DNA B. It is a hexameric protein. Hexameric protein. Okay, with ATPase activity, means it has the function to phosphorylate anything. ATPase activity. Next protein will be the SSB protein. For The fourth protein will be SHB protein.